geometry. Uh, so in transformer 2D geometry, what we did eddy current analysis and then transient analysis, right? So same thing we will do in 3D transformer, but in 3D transformer analysis is same as 2D transformer analysis. Just how to draw the geometry, that is the only thing that differs. Okay, rest all, and how to give excitation also. So just these two things differ. Rest all of the things are same. So whatever we did in 2D transformer, the same analysis is here. Okay. So should we start? We will uh, simulate the same geometry that we simulated in 2D transformer. Okay. I'll just share my screen. Okay. Oh yeah, I just forgot. So this, yesterday I told you I'll tell you how to calculate the average value of this, right? So let's just get finished with this first. So this was our geometry, right? This is the core loss. So one thing you can do is you can directly calculate it from here. Trace characteristic, then recent, and just go to average. Then you will get the average value. The second thing you can do is calculate it in MATLAB. But I don't think it's necessary for you to know how to calculate in MATLAB because it's just coding thing. I can show you. I have written that code. I can show you. Like it's like this. It's just a coding thing. So when your like when your professors will teach you MATLAB, at that time also you can discuss this, because if I'll discuss this now, it's like you will not understand this anyways. Okay. So if you just calculate it from here also, it's fine. Okay. Yeah, you will get, I told you that these are some random values. So some difference you will get, but that's fine. For now, we will stick to this only. Okay. Fine. Is it fine? Okay, fine. That's all. Not saying anything. So we will for drawing a geometry in 3D, first go to Maxwell, then Maxwell 3D. So till now, okay, don't, yes, just create a new project. I have created project in that only. So just create a new project. Go to new. Then go to Maxwell and then 3D. So now you can see in 3D geometry, you have three axes, X, Y, and Z. Uh, in 2D geometry, we were just dealing with X and Y, right? But in 3D geometry, we have to deal with Z axis also. So now it's not just width and height, it will have some depth also. Okay, understood? Fine. Uh, so this is the geometry that we created in 2D, the same geometry we will create in 3D. Okay, so first what we are seeing is a rectangle, right? First, what we have to draw is a rectangle of size 24 into 24. But depth, I'll take it as 8 mm here. Okay. Actually, it's like not compulsory to take 8 mm only. I am taking it as 8 mm because like dimension something we have to assume, right? So it's 24 and 24 and I am taking depth as 8 mm. Fine. So we will see how we will do that. So first thing is it's a 3D structure. So first you have to decide what which part you want to keep as your center, right? Okay, let me share now. Just a minute. You guys, please response. I am not understanding whether like you're getting the things or not. At least say yes or no. Okay? At least that much you can say now. If you are not understanding, you can just tell me. Keep quiet because for me it is difficult to understand whether you're getting the things or not. Hmm. So we have these three axes we have, right? And this will be our 3D geometry of transformer, right? Fine. So here either we can take this as our center, right? Then accordingly we have to draw, or we can just lay it down. We can take this as our Z axis, right? You are understanding? We can take different centers. This thing you are understanding? Why I'm saying we can take different centers. You are understanding this thing, or it's confusing? Okay. So for your ease, uh, we are keeping our X and Y axis as it is. So like uh, what we have kept in our 2D geometry, we will keep it as it is. Okay, so only Z we will change. Fine. So let's see. You have to take rectangle. So this is the 3D structure. Just draw it. Then after first click here, then draw it, then click here and upward. Fine. So this is your the first rectangle that we draw in 2D structure. Okay. So let's just position it. What was our Y size? 24. X size? 24.
20.
Right? Yeah. Z size, I told you I'll take as 8 mm. Okay. So here it will come 12. Here it will come 12. And here I'll keep 0. So I'll just tell you by keeping it 0 how it is. So from it is just like from Z axis, it has not moved anywhere, right? It is not upward from Z axis. So from Z axis, it is at 0 position only. Understood? If I have kept it at some value, it would not be this flat. It would have been in air. You understood?
Yes, ma'am.
Yeah. So we have drawn our first rectangle that we draw in 2D, right? So these some of the directions in which we can see our geometry. First is isometric, right? Then you can see the top view, bottom view, left view, right view, whatever view you want to see. Actually, these views help you to draw the geometry better. Of if you want to see certain things are centralized or not, then these views will help you. Okay, fine. So the second
Okay,
thing
ma'am.
was
Yes.
uh we have drawn the what was the second thing? Windows, right? First we have drawn the rectangle and then windows, right? This part. Oh, this part. Okay. Just draw random. It's fine if you draw like a random for now, but while assigning the position and dimension, you have to be careful. Okay. See, I've drawn it randomly anywhere. Okay. Now you tell me what I should put here, here, and in Y size. If you guys will not tell me, I'll not proceed. Guys are not responding at all. Just tell me what I should put here. You have already drawn your 2D geometry, right? So it's 6 into 16 and Z is 8. So just tell me what I should put here along with position. Any one of you. In what we put in 2D geometry, that you know? What was exercise? It's 6, right?
-8, ma'am.
Where? Minus it? No, no, here. First
8 on
dimension, that then we will go to position. First dimension. So x size is 6, y size was 16, right? And z size, I just told you it's 8. Now, yeah, who was telling me the position?
16. Yes, ma'am.
Yeah, please. What will come here?
Akash, ma'am.
Yes, but what is like, what is the position
-8.
for x-axis? From x-axis, what is the position of this point? It was 2, right? We divided this 3 part equally and we have calculated 4 here. If you guys remember this thing. Do you guys remember this? We have calculated this, right? Then I told you that this is like the center axis and this is 2 mm.
Yes, ma'am. Ma'am, 8, ma'am. -8. The position
What
of
is my,
x-axis is -8.
it's y-axis position. X is 2, right? Here, this y-axis is -8. This I'm saying. This point here, this is 2, right? From center. So for 3D structure, it will depend which direction you want to take and as X and Y. So like, it's not like you are wrong, but according to this, if I have keep 6 here, Y size, and X size 16, then you are right that here it will come -8. But I'm keeping my X size as 6. See, one thing I'll just make you understand by this. Okay. This is just random drawing. This is just random drawing. This is not the geometry. For your ease of understanding, I'm telling you this. I can either draw windows like this, right? This is one of the way. This is one of the way, right? Or I can draw window like this, right? I have two ways. In 3D geometry, I have two ways, right? You are understanding what I'm trying to say? It is which way you adopt. So, see, here, if I'll adopt this,
Yes,
okay,
ma'am.
just wait a minute.
Yes, ma'am.
Now, understood what I'm trying to say? Or should I just explain it again? Mm, Just wait a minute, I'll explain on iPad. Maybe it will be more clear. You guys get it, or should I explain on iPad like what I'm trying to say? Because explaining here will be difficult that you guys are not responding at all. Sometimes it feels like I'm talking to myself only. Okay, fine. Again, how my structure is looking. I'm not very good with freehand drawing, so please excuse me. This is your X, then this is your Y. So now it will depend how I want to draw my window. I have two options. First, I can draw it like this, right?
Ma'am, your screen is not visible, ma'am. That
Is it not
explain.
shared?
No, ma'am.
Oh, it's visible. It's visible. I think only to you it is not visible. My screen is visible, right?
Yes, ma'am, visible.
Yeah. You please check what has happened. My screen is visible because I'm seeing it on my laptop. So this is one of the way to draw window, right? And this will be the second way. So it will depend what I opt for, right? So if I draw like this, then this will become my 16 and this is my 16, it was right, 16 and 6. So my X size will become 6 and my Y size will become 16, right? In this case. In the second case, if I draw like this, so this is 6 and this is 16. So in this case, my X size is 16 and my Y size is 6. So depending on this also, my positions will change. Fine. But I told you I don't want you to get confused. So I'll opt for 2D symmetry. So for 2D, we have taken Y as 16 and X as 6. So I'm opting for this, this one. Understood? This one. You
Yes, ma'am.
understood? Huh. So in 3D geometry, everything will depend how you want to draw the geometry. Okay, fine. So uh, let's see from here only. Okay. Is it confusing? Just imagine that, just look at the axis coordinate system. Just look at the coordinate system and just imagine where you want to put your geometry. And then according to that, just give the positions and size. It's like that. It's like uh, it's nothing like too technical. It's just where you want to place your object. Just according to that, you have to give a size and position. Fine. So I told you that we will follow 2D structure. Okay, where is that? This is that box. Let me draw. Yes. This we will keep 16. This 6 and this 8. So here it will become 2. How this 2 is coming, you know, na? In 2D structure, how we calculated this 2?
Yes, ma'am.
Okay. So we got our first window. Should I repeat this or you guys understood? This you
Understood,
understood?
ma'am.
Yeah. So now what we did after this?
Copy, ma'am.
Into this,
Mirror,
yes,
mirror.
duplicate mirror. Yes, good. Edit, duplicate, mirror. Axis. See, this becomes difficult like this. So we can just change it to some. Okay. You have seen, just by changing the view, I was easily able to mirror it. One isometric view, it was getting difficult for me to mirror. You understood the importance of changing the sides, the view?
Yes, ma'am.
Okay. Now what we did after this?
Cut the portions of the window, ma'am.
Good.
Right, ma'am.
So first the main box, then and then substance. Got this? So now our core is ready. Our transformer core is ready. Does anyone have any doubt in this? How we
No,
have
ma'am.
positioned it, how we have drawn it? Nothing. Everything is clear here till now. Till now, everything is clear.
Yes, ma'am.
Good. So we will proceed to our windings. We will not draw this much of layers. We will just draw this. We have taken it as secondary and primary, right? So we will just draw this two layer, secondary and primary, because drawing this much will take a lot of time. Okay.
Okay, ma'am. Okay, ma'am.
Yeah. Fine. So this is the 2D geometry, but in 3D, how it would have been look. If we will see it in 3D, what we would have seen, I'll just show you 3D transformers. We would have seen some of is See, we would have seen something like this, right? So these are the turn. This is our shell type transformer, right? So these are the number of turns in it. But what we will be drawing is, we will not, what we did in 2D, this is 3D geometry only, just a different view, like top view. Okay. So here we have drawn the cross section of it. But now we have to draw the 3D structure. So this whole thing will come. Understood? But we will not draw these turns. We will draw it as one solid block. Okay? So we will not draw these turns. We will just draw one solid block here, which will go through the mm, just show you how it will look. Just wait, I'll just show you how it will look. So it will look something like this. So it will look something like this, but this will not be turns. It will be just solid block, which will go through this. Understood? Okay, when I'll draw,
Okay,
you
ma'am.
will understand it. For this also, I'll draw one more block. Same, because I told you that we will not be drawing different turns. We will be drawing it as a block. Okay. Now just see carefully how we draw the windings. We have this block. We want to draw this, right? This first thing, right? This is what we are drawing, right?
Yes, ma'am.
Right. So this, what is the size of this? This is 4, right? This is 0.5 and 0.5. So it is 1. And this is 1. So this is 6 mm, right?
Yes, ma'am.
You understood this?
Yes, ma'am.
Yeah. So, and what is the Y size? It's 15 only. There is no change in that. But in Z size, you want 1 centimeter in front and 1 centimeter in back side, right?
Yes, ma'am.
Why? I just told you that it comes out of the, like this, it comes out, right? These windings. So 1 centimeter here and then 1 centimeter here. So now what we have is 8 centimeter, 8 centimeter, I'm saying, sorry, mm. I'm really sorry. It's mm. Everything is in mm. By mistake, if I say centimeter, just consider it as mm only. Okay. So our X size is 6, right? Our Y size
Yes,
is
ma'am.
15.
15.
And Z size is, before it's 8, now we want 1 centimeter in front and 1 centimeter in back, 1 in front and 1 in back. So it will become 8 plus 2, 10.
10.
Understood?
Yes, ma'am.
And its position will be same how we did there in 3D. Just for z axis, it will change. I'll
-8.
-1. Why -1? Because we want, see, now it is at 0. We want in the bottom part 1 right? I told you 1 should be in front and 1 should be at the back. So why I have kept here -1? Because we want 1 at the bottom side. Understood this? I'll just apply and just show you how to. See, now we are not done here. I'm just showing you. See here, 1 we got in front. So similar 1 we want at back, right? But this was the 0 level. That's why we have kept z as -1 so that we will get that 1 in the back. You understood? If I have kept it at 0, it would have been flat here. This part we would have not got.
Level to the core, ma'am.
Huh?
If
What?
if we'll kept z-axis equal to 0, that should be level to the core.
Exactly. It will be level to the core. Okay. And the windings are wounded on the core, right? So it will be like somewhat outside the core. Understood? If we would have leveled it, this would have not acted as winding then. You understood?
Yes, ma'am.
Okay. So this is done, but this solid block we cannot keep as it is. What we want is winding. So how windings are wound? Is it like this? So a solid block placed there? No, right? I want here 1 like I'm just I'm just so this part I want only, right? Now it is whole like this, right? Now it's like this, you are understanding?
Yes, ma'am.
But do I want this? No. What I want is
Winding.
only winding part. So only this part I want, only this much part I want, right? So the excess part I have to remove, right?
Yes, ma'am.
Okay. So for that, we will make another, we will just copy paste this block. I know it will be difficult for some people to understand it, but you have to imagine things. Like I can teach you to some level, but then it will depend on your imagination or how much you can like understand the things on your own. So just imagine how a transformer looks and then you have to draw it, how the windings are wound and all. Okay? I can
Okay.
just teach you to some extent only. Copy, paste. What I want is now it's this, but I want to remove this extra part. This part I have to remove this. This is also there, right? This part?
Yes, ma'am.
Yes. So for this, 15 height will be same. What will change? My x size will change. My x size will change by 5. Why 5 I'm saying? Because point 0.5 here and point 0.5 here, right? This point 0.5 I
Yes, ma'am.
want. So see, this point 0.5 I want and this point 0.5 I want. So that's why this I'm minusing from my original rectangle. So now I'll keep it at 5. When I'll minus it, you will understand it more clearly. Height is same. I'm like not concerned about the height. Then Z also 9. Same. Point 0.5 from bottom and point 0.5 from top. For this, I'm saying top and bottom. Don't consider it as top and bottom. Okay. For our geometry, I'm saying top part and bottom part. Okay. This will be
2.5, ma'am.
5. Good. Very good.
Last
This
one, Z is minus 0.5.
very good. What is your name?
Samir, ma'am.
Good. I think you have understood this. So this part we have to remove now. First this, then this, and just subtract. Now can you see? Now it's looking like a winding.
Yes,
Can you
ma'am.
guys see now?
Yes, ma'am.
Now it's looking like a winding is wound around our core. First it was just a block, right? But we want to create a winding, right? Which is of 0.5 mm in dimension and height was 15 mm, right? So you guys understood how we did this, or should I repeat it?
Understand, ma'am?
Understood now?
Yes, ma'am.
So our secondary, I just told you that we will here we will do only two windings. This one and this one. Okay. So we are done with our secondary winding. So like we are done with this, right? Now we will do this. So for doing this, you don't have to do all of this again. You can just copy paste it and just increase the dimension of things because procedure
Yes,
you have to follow same, right? So you don't have to again draw, subtract and all. Just copy paste this block, copy, paste and change its dimension. Okay, so according to this, you know already what is the dimension and all, right? So according to this, for this winding, this is 0.5. Okay, this is 0.5. Okay, and here also it's 0.5, 0.5. So by how much I have to increase this for the next winding? By how much size by how much value my x size will increase, by how much value my y
8, ma'am.
size will increase, by how much value my z size will increase, that you guys have to tell me. And now I'll seriously wait. I'll not proceed if I'll not get the answer.
Ma'am, X size is 8.
X size is
8.
8. 8 you
Yes,
said.
ma'am.
Yeah. Y size?
Same, ma'am.
Good.
Z size is 12.
Very good. Here, minus 2.
4
And here,
minus 3, ma'am. 2.
minus 2. Right? Now you wanted bottom minus 2, right?
Yes, ma'am.
First, it was just 1. Now we want
4.
minus 2.
Upper one and lower one.
Okay. Very good.
Yes, ma'am.
Now, for the subtract thing, what will come?
Box
Just
5,
just reduce 1 1. 7,
7, 11,
11, 1 minus 1.5,
3.5.
3.5.
Yes,
Apply. Okay.
yes, ma'am.
Yeah. Just something like that wrong or what?
But the spacing is not there, ma'am, by 2 angles, 0.5.
What? What I did wrong?
Between two windings, there is no spacing, ma'am, 0.5.
That we put, right? We didn't put it. Okay. Values I have just exchanged. Sorry, sorry. Here it will come 8.
12.
Sorry. By mistake, I have put subtract value and okay, I might have interchanged it. Okay, okay, fine. But this what I was thinking when I told you to.
2, ma'am.
Good. And then then which value I that time which value I put? Okay, fine. Something I did wrong, right?
Ma'am, this is first winding, ma'am.
No, now it's correct. See,
Oh,
that's why it's important to name your winding.
okay, ma'am.
Has happened to me a lot. Let's name it. Four. That's what's the name? This is box one. This is cool. This is box three. This is secondary
Winding, ma'am.
winding, right?
Yes, ma'am.
And this is primary winding. This is primary. Okay. Now you already know how to assign the core material and all. Okay. Core material, winding materials, you already know how to assign. So let's do that then. Here we will do its transient analysis tomorrow. So for now, I'm just assigning the core material as ferrite only. Okay.
Okay,
So
ma'am.
tomorrow, again, we will do the same thing that we did in 2D transformer. Uh, Maybe by tomorrow we will done with transformer, hopefully. So whatever is left, that also I'll cover. And it's sorry, AC analysis of 3D transformer also I'll do. But there will be no difference in 2D and 3D transformer, means AC analysis of both the structures. It will be more or less same. So it will be kind of a revision for you tomorrow, those who have not understood it at the first time. Okay?
Okay, ma'am.
Yeah. So there are some things that I have to tell you, but I think that we will cover tomorrow. So everything related to transformer or inductors, uh, 2D, 3D, everything that we did for, I think, uh, inductor, right? So we will do the same analysis for transformer also here. Okay. But in this structure only, transformer structure only, we will not draw 3D inductor. We will just do that in transformer structure only. Okay. And
Okay, ma'am.
a few things that a variable, a parametric uh, thing is left. This just parametric study. So this also we will finish tomorrow. Okay. We will try to finish it tomorrow. We will not rush things, but everything related to transformer and inductor, we will try to finish by tomorrow. Just here, copper, right?
Yes, ma'am.
Okay. So now we will change it to solution type of eddy current. Now what is left? First is region,
Boundary, ma'am.
boundary. So here in 3D structure, what we did is we just select a region. We don't do that edge boundary and all. We will just select the environment in which we want to run our simulation. So example, I want my means I want to analyze my transformer in open space. So it's air. If you are designing something for underwater thing, example, it's just an example, and you want to see its behavior underwater. So that surrounding you can change to water like that. So because we operate transformer in open air, so I'll just keep the surrounding as air. So for this boundary, what we do is we don't do anything in boundary as such. We just define a region here. So just click on create region, pad all direction, means this will form a cube. Understood? This will form a cube of equal dimension. Cube is of equal dimension anyways. So whatever you want, just keep it more than the dimension of your transformer. Okay. So my transformer is of 24 mm. So I'll just keep it around 50, or I can keep 100, whatever I want. But just keep it more than your geometry, like transformer dimension, or whatever is your object. Okay. Understood?
Okay, ma'am.
So pad all
Yes,
directions
ma'am.
similarly is it will form a cuboid of 50 mm around this transformer. So it takes the direction from center. Okay, center of the Cartesian system. Understood?
Yes. Yes, ma'am.
Uh, see, can you see?
Yes, ma'am. Very good.
You can rotate it from this option. This option I told you, no, how to use these options and all.
Ma'am.
This is rotate. You can rotate and see from all direction how your transformer is looking. Fine. Now it's we have selected it as vacuum, so we will just change it to air. Okay. See, even distilled water, fresh water, sea water, everything is available. Okay. So you can change your surrounding, means you can change the surrounding depending on the like on which environment you want to test your object. Okay.
Okay, ma'am.
We will just keep it as air. Okay. So this is done. Now what comes? Boundary is done. Boundary like region is done. What comes now? Excitation. Right?
Yes, ma'am. Yes, ma'am.
One more important thing. Uh, see, now you have surrounded this, right? So now, with if you want to do any changes to the geometry, it will be a struggle for you. So what you will do is just select the region and for now disable it. So it is present there, but you will not be able to see it. It's like hide up. It's just hiding there. Okay. So it like uh it gives you that ease to work on your object. Understood?
Okay, ma'am. Understood.
So if you just want to concentrate on your secondary winding, so primary winding, you can just hide it. It is present there, but you are just not seeing it. Understood? And if you want to
Yes, ma'am.
see it, just click on that. Then this unhide. Okay. So this one is hide. This is unhide option. And this is whatever you have kept hidden, all that you can see by clicking this. So one by one, you don't have to unhide it. Okay. This is unhide all in short.
Okay, ma'am.
Okay. excitation to this. First, we will concentrate on our secondary winding. Mhm. So I've I've kept my primary winding as hidden, right? And I'm just concentrating on my secondary winding. So now if I want to give excitation to the winding, I want to have one section in this through which my current will flow. So this should have some cut. Understood? But cut does not mean like you have to assign your coil terminal somewhere, right? What is the starting point of your coil terminal, right? So like through which your current will flow. You have to assign your coil terminal, right? Like we did in 2D. So you have to you have to place one section in this winding. So how to do that? I'm telling. So this will be valid for all the solid structures. So whenever you are not using a wound coil or you're not like you're not using turns and considering it as a solid structure, this method will be very helpful in that particular cases to apply the excitation. Understood? So like after this also we will use this, but you understood for now why we are using this. Okay.
Yes, ma'am.
Okay, so just take a rectangle, draw it, just draw randomly for now. So now what I want to do is I want to place it between this winding, between this, like in center of this. So X, Y, right. So this is like X and Y only, right? This is X and this is Y. So this rectangle I want in X and Y, right? So this is why I have kept it in X and Y. So my X size will be the size of this. So it's 0.5, right? This size is 0.5, right? So I'll keep it here. I'll keep 0.5 here. And my Y size will be size of this. So it's 15, I guess, right?
No, ma'am. 15, ma'am.
15. Now, what I have to do is I have to place it in the center of this. So here it was 2 and this is 0.5. So its exposition is 2.5. Okay. Y position is minus
10. 7.5.
7.5.
Z
It's
is 0.
what? No, Z will not be 0. See,
Minus 1.
why it will be 4 because I want it in the center. If I'll keep Z as 0, it will come near where my what my core is ending, right? But I want it at the center of this. So this is like 8 mm. This is 8 mm, right? If I want it at the center, so it should be at 4 mm, right? If I'll keep it at 0, it will come at the end point of where my core is ending. Okay.
Okay, ma'am.
That's why it's not 0, it's 4 mm. Okay.
Okay, ma'am.
Uh, Let me see if it's fine. Yeah. You can check if it is placed properly or not by 3D model thing. Okay. So if it is showing some error, then there is some error in your model. Understood? So this first coil terminal we have given for secondary, then for primary. Okay. Where is my primary? Now for primary, I'll just copy paste it and move it by hmm,
X-axis.
yes, on x-axis and move it by 1 mm, right?
4.3. 1 mm.
1 mm by 1 mm, 0.5, 0.5, 1 mm, this 0.5, this
Yes,
0.5.
ma'am. 0.5, 0.5.
Yes. So I'll just move it by 1 mm. So now I have sections for both the windings. Uh, You understood this? Is this clear?
Yes, ma'am.
Okay, fine. So excitation, add winding, current, solid, 10 ampere. For the 2D transformer thing during AD current, we have directly assigned 10 like negative positive thing to our windings only. But I told you that we can do it in this way also, right? So this is just that thing. Current 10. This winding addition I told you yesterday. You guys remember this? You guys remember or you forgot? This is for primary. Uh, See, maybe we will not be able to run it today because 3D geometry takes a lot of time to run, and I have not made any geometry and run it beforehand. So maybe keep we will run it today and we will analyze it tomorrow. Okay. So first is this. You you understand this winding things, right? Yesterday we discussed this. Do you guys remember this? Okay, fine. That's I don't know. Okay. Primary current was clear. Primary current, what we put? 10. Do you guys remember what we put as primary and secondary current for our AD current analysis? Let me check. I1 12 and 8. Okay. So primary current, we will change to 12 ampere and secondary to 8 amperes. The same what we did in 2D. Okay, fine. Then this assign excitation coil terminal. This is your primary. Now here they are asking number of conductors. So while explaining transformer, I told you that when you are cutting it in cross section, the rectangle that you are getting as one winding like these, it is having, it is like this, right? And this means it's like this. Why it is like this? Can any one of you answer it? Can any one of you answer me? Hello? Okay. I told you this is not solid thing. It is wounded, right? So we have like a wire that is wounded in shape of coil, but when you will cut it, you will see that it is cut it from a cross section. You will see that it, you will see like this structure. But because it is in one line, we will consider it as a rectangle, right? So this, the number of uh, circles that will be present here is the number of turns, right? Right? It will be what is my number of turns. So the number of conductors that they are asking is that only. So how much turns are there in your primary coil? Understood? I can write any number of turns I want. For now, I'm just writing 100. You can write anything, any number of turns. Okay, like it will depend. When you are designing your transformer, you will have some values, right? For now, we are just taking random values and designing, right? That's why we can put any value. But while you will be designing your transformer, you will have all these values. Okay. If I have, so now question comes, if I have 100 as my primary number of turns, what will be my secondary, what will be the turns on the secondary side? Hmm? What is my secondary current? 8, right? Primary current, 12. Tell me now, turns ratio by turns ratio, tell me now. Guys, please.
I2 upon I1 into N1.
So what is that value? You get of N2 around 150, right? 150 you will get, right? This is basics of transformer. I am not telling you anything related to Ansys now. How this 150 is coming, you guys will see on your own. Okay? Actually, one of you answered it just now. So I think you might understood how this is coming. Okay. Then primary, add terminal, this primary terminal. Okay, so assign call. Inside it. Go. Okay. Okay, direction I have kept same, I think, right? Direction will also change, right? This, this, just, perfect. Here, and this is done. Then mesh operation, right? You guys understood the excitation thing? You guys understood the excitation thing?
Yes, ma'am.
Yeah. So then mesh operation. Assign inside selection. Oh, sorry, geometry I have not selected. This I'm not repeating because you guys already know how to do this, right? So mesh analysis is also done. Mesh operation is also done. Then analysis part, add solutions, setup. The same thing that we did. Frequency, what we selected there? You guys remember?
150 kilohertz.
160. Thank you. 160 kilohertz. Let's validate is something. There is some problem with the fish. We are getting some error in excitation. I was doubting it's pretty quite terminal. Hmm. I'm getting some error in excitation. I'm not understanding why I'm getting that error. They're just asking me to change this to while. But this should not be the case. Okay, I'll just look into it. What is the issue with this? Okay, excitation thing. Tomorrow I'll tell you this. What is the issue with this excitation thing? Why it is not allowing me to keep number of conductors? Okay, fine. Okay. Excitation is done, mesh operation is done, analysis is done. So uh, everything is done, right? So you can just analyze your model, but it will take a lot of time to analyze. I'll just keep it on analysis. Trans 3D trans. After this analysis is, I have selected the field of it. After this analysis is over, we will sorry. After this simulation is done, we will analyze it in the same way that we did with 2D geometry. Okay, and we will see what is the issue with this excitation part. I'm doing something wrong here, but I'm not understanding it now. So I'll just check it once and then we'll tell you tomorrow what is the issue. Okay, fine. So if you guys don't have any doubt, we will stop here. And tomorrow, tomorrow what we will do is we will analyze the 3D geometry mm, for eddy current. Then AC analysis we will do. Actually, I'll do one thing. AC analysis I'll run beforehand so that we will not waste time in tomorrow's class. And also maybe we will do uh, parametric study. The one thing which I just told you, like we do in this way, but we have not analyzed that. You guys remember, right? I told you how to change the core material and all, but we have not analyzed that thing. So whatever, we will just go step by step tomorrow. We will start from day one. Our object, if like how much objective we have covered and what is left, everything we will cover tomorrow. Okay. So we will start from day one till day 6. I think tomorrow is day 6 or 7. till day 7. Okay, fine.
Okay, ma'am.
Yeah, so
Okay, ma'am.
if you guys don't have any doubt, we can stop here. Is- someone is- Do you guys have any doubt?
No, ma'am.
No, ma'am.
Okay. So we can stop here. Actually, my simulation is completed, but I don't want to analyze this for today because I'm not sure about the excitation thing. That's why I'm not analyzing it today. I'll just check once what is the issue with this excitation thing, and then we will analyze it tomorrow. So it has not taken much time. It's fine. Okay, fine.
Okay, ma'am. Thank you,
Yeah.
ma'am.
Thank you, ma'am. Thank you so much for the session, ma'am.
Thank you.